Okay, so for stats today, we're going to have a look at the large data set. The large data set is a collection of weather information in Edexcel, and it's specifically about the years 1987 and 2015. You need to know a few things, such as the fact, for example, that data is collected in May to October these years. You need to be aware roughly of where the different weather stations are and some general trends. So I'm going to hopefully give you some clearer ideas on that today by going through a few questions. Okay, so just a couple of key themes to keep in mind as we're doing this. So most of the weather stations are in the Northern Hemisphere, with the exception of Perth in Australia. Okay, so something that comes up a bit sometimes is that the cities, the towns, etc. in the Northern Hemisphere all kind of have the same sort of pattern, and in the Southern Hemisphere it's sort of the opposite pattern. Perth, by the way, as well, is not sort of what you might think of as like a scorching location in Australia. Their climate's actually quite temperate. Okay, so something to know about that. Jacksonville, we're talking about Florida here. Okay, so famously lots of hurricanes. Beijing, so typically maybe a bit on sort of the warmer side. That reminds me as well, the three overseas weather stations tend to have less data, so fewer of the columns are recorded. So these are all just sort of general hints that help you answer these questions, along with things that I would argue are not too difficult really, like, for example, Camborne by the coast there, quite exposed, is going to be quite windy. Places further north in Scotland tending to be a bit colder than places like Heathrow. You know, Heathrow and Leeming as well. Can you sort of see that they're inland there? So all these sorts of bits of information, that's kind of what you need to know, and a few sort of pieces that we're going to go through. So here's our first question. Bob has 15 days of rainfall data for Camborne in July, but some days are recorded as TR, trace. He wants to calculate the mean daily rainfall over these 15 days. Which approach is most appropriate? Count them all as 0, replace them all with an average of the other days, leave them out, count them all as 1 millimetre. So the answer for this is going to be A. Okay, key ideas in this is you're supposed to treat trace as a numerical value. Okay, so that's often the first mark if they ask you about this. So we need to treat it as a number, and the number means it's very, very small. You can say 0, 0.025, 0.05, I believe, is the biggest value that they expect. So they're happy if you say to treat it as any of these values here. So yeah, there we go. Next, you have mean daily temperature for 6 consecutive months, one after the other, at a UK station. 1 month is missing. The partial data is. So here we go. The temperatures are 11.5, 15.6, 17.8, 17.1, and 14.4. Well, if you've been listening carefully, we've just said that it goes May to October. Okay, so this month here, for example, would be October. For a number of reasons, you can sort of see the trend that we're getting warmer in the middle of summer, and that's starting to go down. Okay, so you would be expected to reasonably know with less information than this. You'd be expected to know this is October. It certainly cannot be April, and as not the warmer month, and near the end, it would be October. Below are some average daily temperatures for a location from May to October in 2015. Here we go. Which of these is likely to be the one that is represented? So we need to have a bit of a think about this. Now, May seems to be quite warm and October seems to be quite warm. July and August might be what we would expect to be very warm, but it seems to be the opposite way around. So this is how we know we are talking about Perth. It's in the Southern Hemisphere, so the seasons are the other way around. They are opposite to that experienced in the Northern Hemisphere. Okay, Herne is in England. Beijing is in the northern hemisphere, and Cambourne again is in England. So this is not a pattern that we would expect to see. Next, consider two UK locations, location X and Y. One of them is coastal, one is inland, but we aren't told which one is which. Based on typical patterns from May to October, which one is likely to have higher mean wind speeds? So X or Y, they're identical, not enough data. Which would we expect? We would expect the one which is coastal. Which places are we talking about here? We'd be talking about places like Cambourne. Where else would we be talking about? We'd be talking about places such as maybe Herne or Loicus. Okay, these would be the kind of answers that we would expect. Where would be considered inland? So a safe answer for that would be Heathrow or Leeming. Okay, so one of the things that you may be asked about is which locations would be windier, and coastal locations is the way to answer that. At a UK weather station, you compare daily total sunshine hours against daily mean temperature. Typically, you might see a positive relationship. More sunshine correlates with warmer temperatures. A negative, so more sunshine, a lower temperature. A perfect correlation, so that they are exactly the same. So every sunny day has the exact same temperature. This sounds pretty unrealistic. And zero correlation. Well, we'd be talking about the top one there. Okay, so just a bit of general awareness, have a think. May to October, if it's a really sunny day, we'd expect generally, but not perfectly, that the temperature would be up there as well. A question a little bit different. In the large data set on a given day, cloud cover in octas was measured. So the idea for the large data set is roughly, if you like, the sky, if you imagine looking straight up, we're dividing it into eighths, and we're saying how many of those eighths are occupied with cloud. That's sort of what's going on here. So we've got some more information. The probability of cloud cover being 5 or more was 0. So it's quite a good idea to start filling out some information. Notice that 0 is there, and 0 is an option. Now, this is the one that really catches lots of people out. You can have 0 out of 8 of the of cloud cover. Okay, so the probability of the cover being 5 or more was 0. So I'm going to put 0, 0, 0, 0. What I'm making here is a probability distribution of cloud cover on this particular day. So something that happens quite a bit with the large data set is it gets mixed in with other questions, and it's just used as a context. So that's sort of what's going on here. So next, the probability of 3 octas and 4 octas was equal at 1/9 each. The probability of 2 octas was 4/9, so it seemed to be very likely on that day to have a bit of cloud cover. The probability of 1 octa was twice of no cloud cover. Well, no cloud cover is 0 octas. This is 5/9, 6/9, so there's 3/9 remaining, and I need to split that in the ratio of 2 to 1. So this is going to be 2/9 and 1/9. So this would be an example of a probability distribution on a given day from the information of how octas might look. So how would you sort of describe this day in general? Slightly cloudy would be the way that we could describe that. For daily mean pressure, so daily mean pressure, in general, it's worth knowing what the columns are in the large data set and what they are measured in. So for daily mean pressure in the UK, which is the most sensible estimate? If you look at the large data set, what you will often find is it's very, very close to 1 1,000 hectopascals. Okay, so 200 is way out. 1,100 as well is far too high. In fact, both B and C are not bad estimates. I think most of the time the values are roughly between about 980 to 1,040 hectopascals. So here we've gone with this one here, but as I stress, B is not a bad sort of estimate. So what's this question sort of testing that you know? It's testing that you just sort of have an awareness really of the unit and roughly how the numbers are distributed. I think there is a box plot question somewhere about this somewhere, the daily mean pressure, and these are the numbers that they use. Okay, so hectopascals. And getting to the end now. So getting to the end of our whistle-stop tour of the large data set. Between Jacksonville, Florida and Beijing, China from May to October, which is more likely to record the heavier total rainfall? So we don't need to have an in-depth knowledge of Jacksonville and Beijing and all their numbers. We just have to remember from our initial look at the large data set that Jacksonville is in Florida. So Florida is heavily associated with hurricanes and sort of having storms, really, I suppose. Okay, so Jacksonville would be a reasonable guess here. It also often sees very high summer rainfall from thunderstorms and hurricanes. Beijing can be wet, but typically Florida's summer rainfall is higher. So I hope you've seen from those questions there that with a bit of time spent on familiarizing yourself with the large data set, it does not need to be something horrible. A small amount of study, 20 minutes, a few times really, making yourself familiar with the large data set is often enough to pick up most of the marks.